All right, so continuing on, I got a couple more of these for us to do. So this is part 3. So here we go. So here's another one. And so once again, we got to start with the leading term right here and kind of evaluate that to figure out our end behavior. And it's positive, so that means as x increases, y will increase. And then the power is even, so I'm going to have the same behavior even if x is going in the negative direction. All right, now it's time to figure out my x-intercepts and if they cross or touch. So once again, I got to factor this. So I'm going to take the equation and set it equal to 0. And so I'll start by factoring out an x squared. And let's see, that will leave me behind with x squared minus 9. And then I can factor the x squared minus 9. That's going to be the difference of two squares. So x plus 3, x minus 3. And so I have 3 unique x-intercepts, 3 unique ones. My first one is 0, and that one's actually um, occurs twice. The multiplicity is 2. So that one will touch and turn around at that point right there. So when x is 0, y is 0. And so that will actually also be my y-intercept because when x is 0, y is 0. So when y is 0, x is 0. So I'm going to go ahead and put that right there. Then my next x-intercept right here would be at x equals negative 3. So when x is negative 3, y will equal 0. Now that has a multiplicity of 1. That one's just going to kind of cut through like a straight line. And so let's see, that's at negative 3, 0. And then I have one more right here, which is going to be at positive 3. And so when x is positive 3, y will be 0. So I have my intercepts, I have my end behavior. I'm kind of ready to at least kind of get a rough sketch of this. And so I have x-intercepts at negative 3, positive 3, and then also at 0. So let me plot those. So I've got one here, here, and here. Now, what I know about my edges, those my at 3 and at negative 3, I know that it crosses kind of like a straight line. So it's just going to kind of go straight through there. And I know that they're both going to go up. So as x goes to positive infinity, it goes up. And as x goes to negative infinity, y goes up. So I can kind of just put kind of a rough little line kind of like that going in each direction like that. So now it's time to figure out what happens in the middle. Well, I know that at 0, 0, it actually bounces off. So what's going to happen is, once again, I'm just going to kind of do a rough sketch, and then we'll find a couple additional points to make sure it's accurate. But it cuts through here. And it's probably going to come down, dip down, and it's going to hit at 0, 0 and bounce off. So it's going to kind of look like that, and then come down and come back up. So it's going to kind of look like a W almost. It's going to kind of looks like it's going to be like a W. So let me erase that though, because I want to make sure I'm really accurate here. Now, if you recognize this, this is great. If you don't, you're going to be okay. But something I do notice is that this is an even function. It's an even function. And so the benefit to an even function is that f of x is equivalent to f of negative x. And so that was something we learned in Unit 2. And so basically what that means is I need to figure out some more values. Like I need to plug in 1 and 2 and negative 1 and negative 2. And like I said, if you recognize this, great. If you don't, you're still going to be okay. And the point is here, whether I plug in f of 1 or f of negative 1, I'm going to get the same result because it's an even function. Because whether I plug in 1 or negative 1, those even powers are going to give me the same results. And so, like I said, it doesn't matter which one I plug in. So I'll plug in negative 1 just so we can see this. So negative 1 to the power of 4 minus 9 times negative 1 to the power of 2. And so see, that even power is going to make negative 1 turn into positive 1 because negative 1 times negative 1 times negative 1 times negative 1. So if you take any negative 1 and raise it to an even power, it's always going to result in positive 1. And if you take any -1 and raise it to an odd power, you always get -1. And that's something we've discussed in the past, but just a little reminder. So that turns into a 1. Then let's see, then I get -9 times, and then -1 squared, that becomes +1. So I'm going to get 1 minus 9, which is -8. And so that will be true for both of those points. So basically, if you can recognize that it's an even function, you can take care of 2 points at one time. So let's see. At 1 and -1, I'm at -8. So let's see. I'm going to go by increments of like 5. So let's see. We're going to go -5, -10. I might have to go further, so I'm going to kind of leave some room in case I have to dip down further. So let's see. At 1, I'm at -8, which is roughly about right here. And at -1, same thing, roughly about right there. So now I need to figure out, what about at -2 and +2? So once again, the nice thing is you're going to get the same result, so you don't have to do the math twice. So whether I evaluate the function at -2 or +2, I'm going to get the same answer. Now, on my previous video, I was plugging it into the factored form, and you could do that if you want to. Or you can plug it into the one up here. The one up here is actually not that bad, but if you want to plug it into the factored form, you'll get the same exact answer. But since the first one I plugged into the original function, I'm going to stick with that. So it doesn't matter whether I plug in 2 or -2, it won't make a difference. So 2 to the power of 4 minus 9 times 2 to the power of 2. So whether my 2 was negative or positive, it won't make a difference, because when I raise it to a power of 4, either way I would get a 16. And then either way right here, 2 squared, I would get a 4. So even if it was a -2, it would still be 4. So that's not going to change anything. So then let's see, then we get 16 minus 36. Ooh, okay, I'm down all the way at -20. So I'm gonna have to dip down pretty far there. Not that big of a deal, it's just a rough sketch. So let's see, I need to go down one more spot, down to -20. And let's see, so I'm gonna dip down to about right there and to about right there. And then just kind of do your best to kind of make this a smooth curve. So I'm going to come down here. It goes down pretty far and then peaks up here. Going to kind of be that parabola shape. And then go back down. And we go up right there. All right, let's look at our next one. So here we are. So once again, we got to start with our end behavior and kind of see what's going on there. So this time it's negative. So whenever I plug in positive x values, guess what? I'm going to get negative return values, so that's going to be negative. Then my power is odd, so when I go the other direction, when I plug in negative values, I'm actually going to get the opposite. I'm going to get positive return values. Now, there's a little bit more to that, but that's kind of following the rule, just kind of not even thinking about it, just following the leading coefficient rule. But if you kind of think about this, you plug in positive numbers, you get a positive number, but then you got the negative, that makes it negative. When you plug in negative numbers, you get a negative return value because of the odd exponent, but then a negative and a negative make positive. So just kind of, once again, kind of taking a little deeper look at that. But you can follow the leading coefficient rule and you won't get in any trouble if you just kind of follow that. So then next, we want to go ahead and factor this and figure out those x-intercepts. So let's see, we're going to take -x cubed minus 2x squared and set that equal to 0. And I'm going to start by factoring out a, I don't have to pull the negative out, but typically that makes my life a little bit easier. So I am going to pull out a -x squared. And so basically I'm dividing it out. So this would turn into positive x, and this would turn into a +2. And you can see if I were to distribute, I'd go right back to what I have up here in purple. I don't want to do that, but just, you know, if you're unsure how the factoring works, you can always kind of reverse it to kind of maybe give yourself a better idea of how that worked. Okay, So now these are my two factors, x squared and x plus 2. So x squared, that solution would just be at 0, and that has a multiplicity of 2, so that means it's going to touch and turn around. So when x is 0, that would make it equal 0. That's what this is right here. It would make it equal 0. So by the way, once again, that will be my y-intercept also. So when x is 0, y is 0 right there. So, and to be honest, that happens a lot. The y-intercept ends up typically being 0, 0. And that will always happen if I get that for my x-intercept because it's right there at the origin and they share that point. My other intercept is right here at x equals -2, and then that has a multiplicity of 1. So that one's just going to cross right through my x-axis when it comes time to draw my graph. So when x equals -2, that also makes the equation equal 0. So I already put my first x-intercept right there, and so my other one's at -2 right there. My end behavior. So gotta be a little careful here. So as x goes to positive infinity, my y value is going to go to negative infinity. So it's going to go down basically, right? So you have to be a little careful right here though, because at that intercept right there, it's supposed to be a little bit, supposed to be shaped like a parabola. So it's going to go down. So you kind of need to draw a little bit with a curve because it's kind of got that parabola shape to it because of its multiplicity. Its multiplicity was 2 right there. So, and then my other end behavior is x goes to negative infinity. The y value is going to go up into the positive direction. Now that multiplicity is a 1, so that should just be a straight line for the most part. It just kind of goes up a straight line a little bit to the left like that. So what I'm tasked with doing now is figure out what happens between the 2 points. Well, once again, I can kind of maybe give a little rough sketch, but we'll get a little bit more detail in just a second. But like I said, this is going to kind of be a parabola shape right here. So this probably kind of comes down and then goes back up like that. It probably is going to look something pretty close to that. And you know, these don't have to be absolutely perfect, but we do want to be accurate. And so that's why we're going to go ahead and figure out what I get when x is -1. So I'm going to evaluate the function at -1. Now, you can plug it into the original or you can plug it into the factored form. It doesn't really matter. I've kind of gone back and forth. So it's whatever you're comfortable with. I guess I'll plug it into the original, but you'll see later on in some other lessons, sometimes it's easier to plug it into the factored form. But I'll just plug it into the original. So let's see, we're going to have negative and then -1 raised to the power of 3, and then -2 times -1 squared. And so let's see, -1 to the power of 3, I went over that up above, that will stay as a -1. And then -2 times -1 raised to a power of 2, that's an even, so that will actually turn to a +1. Okay. So then next, let's see, we got double negatives here, so that will become +1. And then we get a -2 right there. So 1 minus 2 is -1. So we really don't kind of dip down too far. So when I graph this, it just looks like we're going to kind of curve, hit that, and then kind of curve back up like that. And so that's probably fairly accurate. It might kind of dip down a little bit more. I'm not really sure. We're not gonna do fractions and stuff like that. If we did want to get really detailed, we could use a graphing calculator, but I'm trying to have us avoid using those for right now. So, all right, so there's our picture for that, and I got 2 left. Okay, so here we are. So once again, we start with the leading coefficient, and so we look at that and we see, okay, it's positive. So if I plug in a positive x, I'm going to get a big positive x. I'm going to get a big positive y in return, right? And that's the pattern. It would continue to grow. Then let's see, if I plug in a negative x raised to an even power, it actually will turn back to being positive. So, and plus even power, even Steven, even results. So whether I plug in a big positive x or a big negative x, the return value comes back as a big positive and it grows. And that's really what the infinity symbol means. Basically, as x gets larger, y gets larger. As x gets more negative, y will actually get more bigger as a positive number. Okay, so then now we know the end behavior. So there's gonna be some behavior in the middle, but we know that it's gonna go up on the ends, right? That's kind of a general idea of how it's gonna look. But now we got to figure out what does that middle part look like. So we got to find our x-intercepts. So we'll go ahead and take this, set this equal to 0, and factor. So let's see. We can pull out an x squared to get started, and then that will leave me with x squared minus 8x plus 16 equals 0. And then we can factor this, and hopefully you'll notice that the factors are going to be the same. They're going to both be x minus 4. So when you write this, you actually want to write it as x minus 4 quantity squared. You want to put that as a square because there's two of them. That factors into x minus 4, but you want to clean it up and put it as x minus 4 squared. So I have two x-intercepts, and they actually happen to both have a multiplicity of 2. So that's kind of interesting. So we have a solution at 0, and we have a solution at 4. And so I don't have any that cross. They both just touch. So I'm going to have one at 0, 0. And then also when x is 4, the equation equals 0. So my y value would be 0. And once again, like I said, this actually happens quite a bit. My y-intercept is also 0, 0. So let's go ahead and plot those 2 points. So here's 0, 0. Then let's see, 1, 2, 3, 4, put it over here. There's my other one. And then looking at my behavior, I know that it's going to touch when it hits my outside x-intercepts. And then I also know it's a parabola shape, though, and I also know they're going up towards positive infinity. So I have to be careful when I draw this. It's going to kind of look something like that. It's going to kind of have a curve to it when it hits right there. Okay, so that's kind of my general sketch. But now I got to figure out that behavior that's occurring in the middle. Now, once again, I'll kind of give you an idea of what I think it looks like, and then we'll be a little bit more accurate. We'll plug some values in. So I know it's probably going to go up and then come back down. Oops, I need to be a little bit more careful there because it is going to have a curve to it. So when it comes back down, it needs to curve into it like that. So it's going to look something like that, but once again, to make sure I'm nice and accurate, I'm going to go ahead and actually plug in some values to figure that out. So let's see, I need to plug in values like 1, 2, and 3. So I could plug it into the original, but in this particular case, it probably will make my life a lot easier if I actually plug it into the factored form. So this is no different than what's this right up there. So if you want to plug it into the original, you can, but this will actually be a little bit easier if I plug it into the factored form. So f of 1, I'm going to plug in 1 where I see x. So this is going to be 1 squared times 1 take away 4 squared. So then let's see, that would give me 1 times negative 3 squared. And negative 3 squared becomes positive 9. 1 times 9 is 9. So at 1, oh boy, I'm way up there. So this is going to be kind of interesting. Let's see. I guess I need to go by increments of 5 to make sure I can have enough space. So let's see. 5, 10, and I might even go a little bit higher so we leave some extra room there. All right, so at 1, I'm all the way up here at 9. Okay, now let's go ahead and try f of 2. Once again, I'm going to plug it into the factored form. So let's see, that's going to be 2 squared times 2 minus 4 squared. And so let's see, 2 squared is 4. This will become negative 2 squared. And then negative 2 squared will be 4. So I'm going to end up with 4 times 4, which is 16. So let's see, this one pops up a little above 15 when x is 2, about right there. Okay, so one more. Now I need to do f of 3. I'll do that over here. I got a little bit of room over here. And so let's see, we're going to have 3 squared times 3 minus 4 squared. So 3 squared is 9. Then this will become a negative 1 squared. Then let's see, negative 1 squared becomes positive 1. And then 9 times 1 is 9. So that one's going to be the same height as for f of 1, so about right there. So it's going to be pretty symmetrical, it looks like. Okay, so now just got to be careful when I draw this. I've got some curve to it. You don't really want any sharp turns if you can avoid it. And then this must kind of dip down like that. And there we go. Okay. All right, so I have one left, last one. All right. So once again, we'll start with our, we'll start with our end behaviors. And so we look at this term right here. So since it's negative, when I plug in positive x values, they're going to spit out as negatives. So as I plug in really big positive numbers, I get big negative numbers back in return. That would be the pattern. And then if it's even Steven, it's going to have the same behavior, because even if x were negative, it won't make a difference because the power of 4 will make that positive. But then I got the negative that's on the outside right there. All right, so now we need to go ahead and find those x-intercepts. So we're going to go ahead and take this and set it equal to 0. And let's see. Once again, the leading term's negative, so ideally I want to pull out a negative with this. So I'm going to pull out negative x cubed, and then I'm going to, let's see, that'll leave me with positive x minus 3. So that's what I'm left with there. And once again, you can double check that if you want to by distributing it back in. And so let's see. So this is going to be different. We haven't had this happen yet. So I have a solution at 0 with a multiplicity of 3. And then I have positive 3 as a solution with a multiplicity of 1. So since they're odd, they both cross. So at 0, 0, I'm going to cross. And at 3, 0, I'm going to cross. And I did not have any even multiplicity, so I don't have any that just kind of touch and turn around. Now my y-intercept, I will have that at 0, 0 also. Like I said, that happens a lot. So now when I graph this, I gotta be a little careful because my multiplicity of 3 is gonna kind of have a, it's gonna cut through it, but it's gonna kind of have that twist. It's gonna have a little twist as it hits it, as opposed to when I cross at 3, it's gonna be more of kind of a straight line. It's gonna kind of mimic a straight line. But for my multiplicity of 3, gotta be a little bit more careful. So let's see, I've got an x-intercept here at 1 and at, let's see, 1, or I'm sorry, at 0, and then let's see, 1, 2, 3. Over here, I've got another one. So my end behavior is both, they're both negative, so that means they're both going to go down. And let's see, at 0, 0, I have to be careful though, because it's going to kind of twist down. It's going to kind of twist going down, and then it's also going to kind of twist going up. It's going to kind of go up and then come back down right here. But now I got to kind of figure out, okay, so twist, it's going to twist going up and come back down. So I need to figure out what f of 1 is and what f of 2 is. F of 1 and f of 2. So once again, this one, I don't think there's really an advantage whether you plug it into the original or the factored form. It's not going to make a difference. So I'm just going to stick with the original. So I'm going to do f of 1 to start. So let's see, that'd be negative, and then 1 to a power of 4, plus 3 times 1 to a power of 3. And so that negative's on the outside, so you do the power first. So the power, 1 to the power of 4 is actually just 1, and then you apply the negative after the fact. Then I have plus 3 times 1 to the power of 3, which is 1. So I'm going to get negative 1 plus 3, which is 2. So at 1, I'm up here at about 2. And then now let's go ahead and figure out what f of 2 is. And let's see if I got some room right here. So f of 2, let's see, that's going to give me, let's see, so I'm going to have negative parentheses 2 to the power of 4 plus 3 to the power of, I'm sorry, 3 times 2 to the power of 3. So I got a little bit of algebra to do here. So, oops, here we go. So let's see, that negative will get applied after the fact. So 2 to the power of 4 is 16, and then the negative comes with it. Then plus 3 times, let's see, 2 to the power of 3 is 8. 2 times 2 times 2. So then I'm going to have negative 16 plus 24. And so let's see, negative 16 plus 24 is 8. So at 2, I'm going to be all the way up at 8. So that might be a little challenging to graph. Let's see, let's see, maybe I need to go by increments of 5 probably, just to kind of make this a little bit easier to do. So let's see, we're going to go by 5, 10. That'll probably make this a little bit easier to plot. So let's see, at 1, we're up here at 2, which is about right there. And then at 2, I'm up here at 8, about right there. And so now we'll go ahead and try to draw that with a smooth curve coming up, and then smooth peak here, and then come down pretty quick, and right there. Okay. So anyways, hang in there. And so I'll have this, the graphing part of the homework assignment, I will give that to you guys on Monday. Okay. So for now, try to do the part that is on the computer, and I'll give you part 2 of the homework on Monday. I'll see y'all then.